Astronomy and Astrophysics Club of Central University of Tamil Nadu. Today's speaker is Dr. V. Madhurima, Professor, Department of Physics, CUTN. Her field of specialization is experimental and computational condensed matter and wetting studies. She is also a visiting associate of the Inter-University Center for Astronomy and Astrophysics, Pune. Due to her great interest in historical aspects of Indian astronomy, we didn't have a second thought in inviting Professor Madhurima to deliver a talk on the tradition of Indian astronomy. So we will be joined by Dr. Tia Sheshadri, who is a professor, Department of Physics and Astrophysics, University of Delhi. We are also blessed to have the presence of other faculties from Department of Physics, CUTN. So I request all of the participants to ask doubts without hesitation, and you can also type your doubts in the chat box, which will be discussed at the end of the talk. So let's start today's session. I hand it over to Dr. V. Madhurima. Please go ahead, ma'am.
Thank you, Devika, and thank you everyone for this opportunity to be sharing a few thoughts with you. Right at the offset, I should tell you that my interest is basically in Indian cultural history more than astronomical history. But when I was asked to give this talk, I was pretty happy to go and dig into my old notes and see what I can do. So I clearly, because this is going to be about Indian astronomy, there will be an overlap with certain religious aspects. But this talk is not about religion. And the second thing I would like to say is, again, because the focus of the talk is on Indian astronomy, I will be speaking only with perspective of Indian astronomy. This is not to say that there are no other branches of ancient astronomy, or that this was in isolation and this Indian astronomy grew on its own. Wherever possible, I will mention the links, but this is just a small disclaimer before I start. So I hope everything is clear and you can hear me. Devika, if you can confirm.
Yes, ma'am, it's clear.
And you can see the slides, right?
Yes, ma'am, it's clear.
Wonderful. So thank you very much. So before we go on to ancient Indian astronomy or the historical traditions of Indian astronomy, it is good to know what do we mean by ancient and what exactly is the frame of reference that we are talking about. Now, nobody really knows how to date Indian history because we didn't have a written tradition. What we had was an oral tradition, but the oral tradition was maintained very well in a fairly scientific manner. We can discuss about that later if you want. To the extent where there is no doubt that these texts are old, but how old they are, one doesn't really know. So there is a conservative way of looking at all these texts, and the conservative estimate is that around 3000 BCE, before the Common Era, what you would have known before as BC, there was possibly an Aryan migration, not an invasion, but a migration, but even that people are not very sure. And the Vedic period is tentatively dated between 1500 to 500 BCE, but one is not very sure for the following reason. This particular river, the Saraswati, is mentioned in great detail in the Vedas, the Rig Veda, and that had dried by about 2000 BCE, which means that the Vedic period should be even earlier than that. But this is the problem that is there in dating anything that is Indian. So I'm not going to go into the controversies of this or the arguments, but I personally am of the opinion that the dating with respect to the Saraswati River is important, and most of the times can be actually pushed even back. But no matter what, the Vedic period was followed by the Upanishadic period and then the Puranic period. Puranic period is all in the Common Era. So why is this important? Because when we go through the talk, we'll be looking at various texts, and it's good to know where we place these texts. So there are other texts also of equal importance when we are studying any aspect of Indian cultural history and even in astronomy, which are the Ramayana and Mahabharata, possibly much older, but conservatively placed around 500, 400 BCE, and both are thought of to be written around the same time, 100 years this way, that way. And then there are these Vedangas, which are the auxiliary texts that are useful to study the Vedas. And this is basically mentioned in what is called the Brihadaranyaka Upanishad, which is again conservatively dated to 900 BCE. So at least 3000 years before now. The Vedangas have 6 branches to them. The first one is called the Siksha, which tells you how to pronounce the mantras that are there, phonetics and pronunciation. The Chandas, which speaks about the poetic meter. The Vyakharana, which talks about the grammar and the linguistic style. The Niruktas, which talk of the etymology of the words are there. Kalpas, which give the ritualistic instructions about how to do the rituals, and Jyotisha, which tells you the auspicious time. Now, for the rest of the talk, we'll be interested in the Kalpa and the Jyotisha. Kalpa was based on what are called the Sulba Sutras. These sutras were given to tell how to construct a fire altar where the homas are done. These were highly geometric. I'll be showing you an example or two at a later stage. And the Sulba Sutras does hence have a lot of formulae for geometry and various kinds of geometry. Sulba actually means rope. And because there were no scales or anything in those days, all the length measurements were done using the rope. So these are the rules of how to use the rope to make measurements, very accurate measurements. Why is this important? Because Sulba Sutras most probably are the oldest existing texts on geometry anywhere in the world. And that geometry is the one which actually evolved for many centuries until they started using it in astronomy. And now Jyotisha is to find the right time to do these rituals. That's all it was there in it. Jo is the Jyoti or the light. So it's basically a study of light, which meant they were looking at light from celestial sources and deciding which would be the most appropriate time for the rituals. So on the one hand, this is the reason I said that we will be having a slightly religious element to the whole thing, because all these studies started off as a part of the religious practices of those days. So the Sulba Sutras taught the priests how to build the altars, and the Jyotisha told them what would be the correct time to be performing these rituals. So history of Indian astronomy can be split into various eras, a prehistoric part, a Vedic era. Doesn't matter how old it is, but it's up to about the 5th century. And then the period of the 18 Siddhantas, which is between 5th century before Common Era to 5th century Common Era. And then the classical era, something that we are all aware of, and post-colonial, colonial and post-colonial era. So let's look at this in a bit of a detail. In the prehistoric period, people were very fascinated by what they saw in the skies, especially the phases of the moon. And these observations have been across the world, like, just looking at the phases of the moon and marking them. So the observational part was common everywhere, but how they interpreted it depended on the cultural framework from which the people came. So this knowledge of looking around the nature, and along with all other knowledge accumulated, is what led to very regional, theological, and philosophical world views in each area. So observations were common, interpretations depended on their cultural framework. So 2 examples of astronomical observations in the prehistoric era. The first one here onto the left is a lunar calendar stick from the Nicobar Islands, where the waxing and waning phases of the moon are recorded. This stick is apparently from at least 11,000 years before the common period. So almost 13,000 years ago. So people have been observing it. Now, the one on the right is a very famous Mohenjo-daro seal. You must have seen it in your school texts. There is an interpretation to this saying that this could be the Saptarishi Mandala, which is also called the Yerumeen in Tamil. And it could be the Ursa Major with the 7 lines to represent the 7 stars. And this is a mean. So 7 mean, the Tamil version of the Yerumeen. This is again a bit of an interpretation because one is not very sure. The next small example, this is from Hanamsagar in Karnataka. I've taken these from Vigyan Prasar documentation. Apparently, in this place in Karnataka, there are 50 rows, each containing 50 blocks, so approximately 2,500 stones that are separated by 12 meters from each other. And the lines are oriented in the cardinal directions. And in the center, there is a structure known as the Chakrikatti. Next place, we'll see what they were observing is that the movement of the sun and the moon, and with respect to the summer solstice and the moon's solstice, these stones were placed so that they knew when to expect the seasons. So it could have been used for prediction of monsoons and basically for agrarian purposes. Now, in the Vedic period, the emphasis was on nature worship. If you happen to read any of the translations of the Vedas or in the original, you will see that the older texts are nothing but nature worship. No astronomer, whether it was Aryabhata, sorry for the 2 T's, it should have been 1 T there, or Padhani Chandrasekhar in the 19th century. He is a very interesting person from Orissa who could make measurements about the Earth-Sun distance using just bamboo sticks and some very minor, tools. None of them mention the Vedas. They only talk about the Vedangas. I mean, the first slide we saw that the Vedangas are a much later set of texts compared to the Vedas. The Vedas consist of shlokas on nature worship and of rituals about how to appease these natural forces. Vedas contain a few elements of astronomy. They speak of the new moon, of the full moon, of the 28 nakshatras, of eclipses, seasons, months, days, years, and longer periods. Just to understand the cultural framework in which the development of all this happened, according to the Vedas, the universe is originally was united, in the sky and the earth were united, and they were separated by the atmosphere. And so it is called Antariksha. It is something that is between the two. The Antariksha in the later texts was replaced by Patala. So we have a threefold division of the gods and of nature. And it was the earth, the skies, and the atmosphere in between. In much later texts, the atmosphere was replaced by what is now we understand as Patala, that is Akasha, Prithvi, and Patala. The gods also in this period were divided among the 3 regions. So Dew is the celestial sphere or the god of the celestial spheres. So Dew Sthana Devatas were Varuna, Savitra, Vishnu, and Pushan. Pushan was a pastoral god. And Antariksha gods were Indra, the thunder god, Parjanya, Rudra, the howling wind, the Marutas, the other kind of winds. And the Prithvi Devatas were Agni, Prithvi, Soma, and Brihaspati. Soma being a plant and Brihaspati in general representing nature. While these were observations carried forward to many, many centuries, they were also theories of how the universe was created. Now, what is interesting to note is that even in the Rig Veda, there are many opinions about who created the universe. So one shloka says it's Indra, the other says it's Vishwakarma, and so on and so forth. The other Vedas also have a different opinion. So the creation theories were very different for different streams of thought, and they continue to be so for the next, even I think to date. Where observations were confirmed through experiments, they were accepted universally across all schools of thought. There are 6 old schools of thought of philosophy, and all of them accepted whatever was observationally proved. But what they could not prove, which is like how was the universe created, each one had their own take on it. So the other thing I would like to really emphasize here is Shastras, no matter where you see them, they were never prescriptive. They were only saying that this is what we observe. And if you want to follow it, follow it. If you find something which has a local variant, feel free to add or subtract. And if you want to contradict whatever is in the Shastra, there were rules to contradict. They only said that please quote the previous or the Shastra that you're contradicting in totality, not in pieces. I mean, this is very, very important today when you hear people taking a small bit and blowing it out of proportions, and quoting things out of context, especially in the news. That is not an Indian tradition. The Indian tradition said, quote the entire thing in totality with respect and stick to the point and contradict what you want to contradict. So Shastras have never been prescriptive. Just because something is said in the Shastras, no, you were not expected to follow it in toto. But if you were not following it, you were supposed to give enough reasons for why you are not doing so. Similarly, I have heard that whether it was the Charaka Samhita or Sushruta's text, these were their personal theses. So it's not textbooks for others, but their observations and theses. And that is how knowledge was propagated. And this is something we really have to, I think, bring back into the way we think today, because contradicting what is available is an accepted form of Indian knowledge. However, the only few rules are be polite, be truthful, quote the entire text, and don't attack the person who wrote it. I think these are beautiful rules to follow even today. So speaking of time, worldwide, there are 2 views about time. There are cultures which look at time as a linear progression from the past to the present to the future. And there are cultures which think of time as a cyclic or a circular event. There have been many, many cultural studies on this, and people have seen that there are attitudes which are associated with each form of thinking. So typically, if an entire culture believes in a linear progression of time, they don't want to waste time. They want to complete tasks sequentially and so on and so forth. Whereas circular time, everything is repetitive. People, aaj nahi to kal, if not today, tomorrow. Values are in long-term relationships. And there is a belief that life controls time. And Indian Southeast Asian culture is typically a circular time believing one. We believe in the coming back of every era, and hence a certain change in attitude. So this particular idea is reflected in the way we look at everything around us, including the way astronomy was seen. So being at the center, you look at how the world moves around you, how the universe moves around your Earth, and then it was split into various seasons and years and everything. Every part of it being repetitive. You might say that this is common even to the Western culture, but this was extended to much larger periods like the yugas, and how the entire universe will be destroyed and again it will be recreated. So the circular aspect was taken from the smallest to the largest unit of time. So there was overlap of the way these days, months, and others were calculated. There were the solar calculations, the Savana or the Dhruva calculations, or the lunar, the Tithi-based calculations, and the stellar, the Nakshatra-based calculations. And this is the reason why we have, New Year happening at least 7 times in South India. The Gregorian calendar, and then the Andhra New Year's Day and the Tamil New Year's Day, and then comes the Malayali New Year. So because each one is following a different system. By the by, the Tithi is the moon rise, is that time at which the moon rises in the east horizon, and it is predictable. So the opposite of this is Atithi, something that's not predictable. So someone who comes without telling you is called an Atithi. Someone who comes without the knowledge or untimely. So these are just details to tell you what the names of the Tithis look like. But what is interesting is that the Tithis had names, okay? And these names were different for day and night. And they were, basically looking at when you were looking at the moon, they had different kinds of Tithis. And there were 60 such names. And they are all named in the text. Now, depending on the phase of the moon and the day, whether you're looking at the waxing phase or the waning phase, each one had a different name. Why am I emphasizing on this? Because, yes, Sesh, you have a question.
Yeah. Just a comment. When you say that the repetitive nature was built into the Indian system, basically it also has to do, I think, with the fact that there is no special zero of time. Just like we say homogeneous universe, it is also homogeneity in time, right?
Absolutely. See, that's true. That is true. Because when you have a linear system, it has to start somewhere.
Yes. Yeah. Okay. Yeah.
You don't have it. That is true.
Yeah.
Yeah. Yeah, thanks for that. Now, what I was trying to say here is that one of the reasons why the Indian system had names, even for numbers, I don't know if I'm going to be talking about it, but even the numbers were coded into words, was because most of it was oral tradition and we didn't want to lose the data. And the second was, even at a later stage, when things were written down, they were written down on these talapatras, on these palm leaf manuscripts. So when you write on them, the numbers were far more difficult to write than the letters. So everything was codified, and the reason why we have short shlokas or sutras was because they had to be put onto a palm leaf. So a lot of it was dictated by the fact that whatever they were communicating had to be concise, written in 2 lines, and should stay on the talapatra, because imagine taking a sharp instrument and writing on a palm leaf. You didn't want scratches that could be misunderstood when read by somebody else. So those were the constraints, and it is within these constraints that all these texts were written, and hence they seem very, very cryptic unless you learn the language and learn how to interpret it. So the day itself was divided into 2 major parts, the forenoon and the afternoon. And of late, I think people are beginning to use these words back. And the Purvana was itself divided into Prataha and Samvaga. Like Samgava is the time when the cows were taken out to graze. And similarly, the afternoon was divided into Madhyana, and then the coming back of the cows, and then the Sayatra, and so on and so forth. Some of these words we are still familiar with, like, Sayan, Pra is something we use regularly. This 5-part division was at some point superseded by a division of the day into 30 muhurtas. So 15 for the daytime and 15 for the nighttime. So this word muhurta is something we know from, especially weddings, this. So this is the muhurta. So muhurta is 24 hours divided by 30 is 1 muhurta. Numbered hours are probably from Egyptian astronomy, and so are the 12 zodiac symbols. They are not indigenous. And these are proofs that there was a constant transfer of knowledge from India to the other countries and back. And we also have this vague feeling that, there's been a transmission of information from India to Southeast Asia, to Bali, to Indonesia, and to other places, but not westwards. But there is enough proof that there has been very good communication across all these continents for a very, very long time. Just as the day was divided into parts, the year was also divided into days, months, seasons, and half years, ayanas. I like the Vedic months names. Madhu, Madhava, Shukra, Shuchi, Nabha, Nabhasya, Isha, Ujja. These are very interesting names.
Madhurima, I can understand why you like the names as it starts. No?
Obviously. No, but Madhu Madhava and Bharati Madhava are very interesting names because they also have a classical literature connotation.
Okay.
They are used a lot by the playwrights from around the 5th century Common Era.
Okay. I just have one question.
Sure.
At what point did the concept of weeks come into play? The weekdays.
The weekdays is much later. I think I might be having it in the next slides.
Okay.
What point I don't know, but it's definitely from Babylonian, Greco-Babylonian influence.
Okay.
Because we don't have that.
Yeah, that's what I thought so, yeah.
Right. So now, we already discussed that we have calendars which are solar based, there are calendars which are lunar based, and then those calendars which are based on the way the stars are in the skies. So there was a problem when you are trying to align all of them, and the disparity between these calendars was resolved through what is called an Adhikamasa. An Adhikamasa means basically an extra month, and it was like a leap month, like we have a leap year. At the end of every 5-year cycle, an additional month was added, and then all the calendars were combined together. Because they were combined together, this was called a yuga. So in a normal language, yuga simply meant 5 years. And Ugadi, I mean, this is something that was always bothered me, that we call New Year's Day as Ugadi, and I'm like, why is it the beginning of a yuga when it is, coming every year? But looks like yuga means something much shorter. It's just the point at which two things meet, or there's a conjunction, right? The other planets that were mentioned during the Vedic period are 5 planets, but only 2 by name, Brihaspati and Vena. The name Shukra was Vedas. The Saptarishis constellation was known. The pole star was known, Dhruva. And the brightest star in the southern hemisphere, the Canopus, had suddenly become visible during this period. I'll be discussing this in a little bit of a detail. And this was called Agastya. And a prayer in the Atharva Veda mentions comets and meteors. So the Dhumaketus. One of the problems that later day astronomers had was they concentrated solely on planets. For some reason, the meteors and comets were not.
Madhurima?
Yep.
I think this Ulkani and Dhumaketu, it is the other way around. Comets are Dhumaketu and meteors are Ulkani.
Oh, thanks.
Yeah,
sure. I'll make a note of it. You're right. Yeah. Comets are Dhumaketu because they come with the tail, right?
That's right. Yeah.
So, short digression here. I'm going to go through some mythology, some stories, because I promised to tell you some stories. The first one is about the Dhruva Star. So, Dhruva mythology is at least from the Mahabharata, if not older. So, in the Mahabharata, it's mentioned that there was this son of a king. The king had 2 wives, and the younger wife was very strict in not allowing the older wife's child, Dhruva, to be interacting with his father. So he asks his mother, "What can I do? I'm feeling." So the mother says, "Go and pray to Vishnu." He goes and prays to Vishnu, and Vishnu gives him a boon. He says, "What do you want?" He says, "I don't want anything." So he's a person who's very, very firm because he really doesn't want anything. So he was then elevated to the status of being a nakshatra, a Dhruva nakshatra, and he is placed in a very firm position in the sky. Now, what is interesting, the same Mahabharata mentions that Abhijit, the star, the nakshatra Abhijit, was the pole star and it had fallen in the skies by the time of the Mahabharata. Now, what does all this mean? Is that because of the precision, what looks like the firm North Star around 5000 BC was Abhijit, and by the time the Mahabharata was written at a later stage, it moved, and Abhijit came down from 90 degrees to 40 degrees, and that's something that has been documented. The other interesting thing is that this Saptarishi Mandal goes round the Dhruva Nakshatra. The mythology says that the rishis were so impressed by a young boy that they decided to go around him to show their respect. But you can also see that this could be the possible origin of the swastika as a very important symbol in Indian cultural tradition, which unfortunately has a wrong connotation now. This is a very interesting interpretation. Whether it's right or wrong, I mean, nobody knows. Actually, nobody knows. Like it. The next one, this is an article from the Current Science, which talks about how the Dhruva Nakshatra actually moved in the skies over the years, and from which point it would have been visible. So it turns out that in 10,000 BC, the star could have been visible only up to Kanyakumari, and then it moves forward, and now we can see it, I think, up to Kurukshetra, and then it'll it'll go back. This is why Agastya is said to be the sage of the southern region, and the whole story of Agastya being sent southwards. There's a lot to be interpreted with these mythologies, and some of them at least have very astronomical connotations. The other story is the Vishwamitra and Trishanku. This is a famous story of Vishwamitra, who is basically a king, a Kshatriya, who wants to become a well-established, known sage, Brahman. And the only person who can confer that on him is Vashishta, who refuses to acknowledge him. So there is this fight, and there is this person called Trishanku, for whom Vishwamitra builds a whole new world. Now, one of the interpretations is that this basically represents the Southern Cross, which is the 4-star system used extensively for navigation in the Southern Hemisphere. And there are reasons to, similar to this, there are reasons to understand the Southern Cross to be the combination of Vishwamitra and Trishanku. Trishanku having 3 stars and Vishwamitra being the 4th in that. So it's quite possible that Agastya, Vishwamitra, like the rest of the Saptarishis, are basically stars. Being in Tamil Nadu, I think we are all aware of this Aradra Darshanam that happens sometime around January, where it's a major festival in Chidambaram. Now, Chidambaram is supposed to be one place up to which the star Agastya was visible, and the Nataraja there is thought of to represent the Orion constellation. And sorry for being lost. It's when people enter the room, I have to allow them, and so I get a bit distracted there. Aradra itself is the Betelgeuse, the star there, which is the brightest one. And when it dimmed, there were quite a few people who were wondering what would happen, because was Nataraja having a problem? Well, right now we don't seem to have a problem. This is, I think, by an article by many, but specifically Sharda Srinivasan, who writes about the iconography of Nataraja and also of this particular legend. And then there is this entire story of the eclipses. The left panel represents the Amrita Mantana, where the Asuras and the Devas, churn the milky ocean to get nectar. When the nectar comes, Vishnu in the form of Mohini ensures that only the Devas get the Amrita. One Asura, Swarnabhanu, by deceit drinks this. So Vishnu gets angry and beheads him, but because he has drunk the Amrita, he is immortal. So there is a serpent body added to his. So one part is the human head in the serpent body, which is the Ketu, and the other is the other way around, which is Rahu. And these are supposed to be the two demons who devour the sun and the moon, because the sun and the moon are the two devas who actually tell Vishnu, look, there is this wrong person sitting in our crowd. So they are very annoyed with it, and they end up eating up the sun and the moon, and those are thought of to be the eclipses. But the other interpretation is that Rahu and Ketu represent these points, the nodal points of the rotation of moon and earth around the sun. These 2 points, the southern and northern point, being called Rahu and Ketu, because these names do not exist in the Vedas. And here again, there is a problem in interpreting. Are these simply mythological stories, or are these stories created as mnemonics for astronomical data to be transmitted because it was an oral tradition? So this is the question that's a broader question that is being asked. Yes, Kaviraj, the first picture is from Indonesia. That's right. The next legend is that of Rohini, the favorite wife of Chandra. Moon is supposed to have married the 27 daughters of Daksha, and Rohini was one of them. And Chandra was extremely fond of Rohini to the point where he started neglecting the other wives. So Daksha curses him that, he will moon, that Chandra will simply vanish. And the story goes that Chandra goes to Shiva, and Shiva says, look, it's okay, you will wax and wane, but nothing will happen to you. It so happens that there is this phenomenon called occultation. That is, when you look from the earth, see the moon, and the star gets hidden behind the moon. Turns out that this particular star, Rohini, is the one which has the maximum occultations. And that's possibly the reason why the whole idea that moon is fond of Rohini comes. So again, one more story to go there. So that's all for the stories there. So they're not really stories. One needs to ask whether these are simply mythological stories or do they have data that we can interpret. Now, the same astronomical phenomena were also used to date some of these texts. So the Vedanta Jyotisha has two overlapping recensions, sorry for the spelling out there. One attached to the Rig Veda and the other to the Yajur Veda. Both versions say that the winter solstice took place at the Shravishta Nakshatra, the Dhanishta Nakshatra. And today when we do a backward calculation, you realize that this would have happened in the year 1400 before CE. So you can date texts based on the astronomical data quoted in the texts themselves. Similar attempts have been made to date the Mahabharata. I think many people agree with this, this particular idea of 1500 BCE. Although I have seen, I think Nilesh talk all the way up to 5000 BCE and so on and so forth. The problem with an absolute dating is the fact that because of precision, the stars also move, and how much of data agrees. Like across the text, you want to take all the data points and then fix them. Some of these arguments are based on just one or two events in the text, and the others would have taken into account all the events that are mentioned. So again, just coming back very quickly to the Sulva Sutras, these were the ones which told you how to make measurements. The one on the right is just names that I wanted you to know. The oldest book of astronomy is the Vedanga Jyotisha, which is attributed to a person called Lagada. And in that, it's mentioned that Kala Digdesha Jnana, like the idea of astronomy in those days of Jyotisha, that study of light, was for the purpose of knowing time, direction, and geography, Desha. Because Vedic rituals had to be done at a specific place at a specific time, this became important. And so the entire set of calculations were for that. So based on this, we move to the next period, which is the 18th Siddhanta period. In addition to Muhurta, there was now a concept of a Nadi, which was one Muhurta was 2 Nadis. It's one additional term that was used. So there were 4 types of astronomical texts being written from that period. The Siddhantas, which had theory and proof, the Bhashyas, which were commentary, the Karnas, which were basically tables for the astronomer, and the Panchanga, which was for the general public. I'll talk about the Panchanga because this is something that all of us are aware of, and I have seen my aunts quote these and make calculations without even having to bat an eyelid. So Panchanga has 5 angas. This is basically a book that is available with everyone, at least in the villages. Everyone used to have it, a copy of it in the house. Come New Year and you will purchase a Panchanga and keep it there. It has 5 parts to it, which are the Vara, Tithi, Nakshatra, Yoga, and the Karna. And based on these, certain calculations would be made, and they would know when the monsoon would begin, when the monsoon would end. I'm sure it will not work right now, given the amount of environmental crisis that we have, because for some odd reason, it's been raining here since afternoon. I mean, it brief rains, not expected. But I think even up to my 20s, this was very, very predictable. We knew when it would rain and when it would not. The first one is the nakshatra that will take up. Nakshatras are the 27th part of the ecliptic, the plane of the Earth's orbit. And each nakshatra thus occupies 13 degrees and 20 minutes. The time of the moon, the time that the moon takes or any other body requires to travel through this 27th part is called a nakshatra. The moon travels daily 1 nakshatra and we have 27. Originally, there used to be 28 and then it was reduced to 27. I'll come to that in a minute. So the 27 nakshatras, are also seen in when somebody's astrological chart is written. It's basically you're standing at Earth and look at the time of the birth, you look towards east or towards where the moon is. If you look towards where the sun is, it gives you Rashi. When you look at the moon, it gives you the nakshatra. You look in the direction of the moon and see what is behind it, and that is the nakshatra that the child is born in. At the time of birth, where the moon is and what is behind the moon. And these calculations, these are purely mathematical calculations. And sorry, didn't mean to do that. Yeah, and these are the 27 nakshatras as given in the Atharva Veda. Originally, there used to be 28, but they realized that having 28, 360 by 28, the calculation became a bit more messy. So the 28th Abhijit, this is the Dhruva nakshatra I mentioned before, was dropped. And now we are having 27 nakshatras. This is a panel from the Audayar Kovil, and for some of you who are from the Maths department, that's Dr. Chandrasekhar, we had gone there to visit, and this is a list of the 27 nakshatras on one of the temple walls. A tithi is the time occupied by the moon in extending its distance from the sun by 12 degrees. So, I mean, the picture explains it all. And you go from Amavasya to Prathama, Dvitiya, 12, 24, 36, and go all the way around and come back. And the 180 degrees one is called the Purnima, and you come back. A Karna is half a Tithi, and there are names. These are strictly for the sake of calculation. This is a bit more complicated thing, which is about, there are fixed Karnas, there are, movable Karnas. This part is mostly for astrology than for astronomy, because depending on which one of the Karna's child is born, they would attribute characters to the child. And then, of course, there are the Vara. This is what Sesh, you were asking some time back. As you can see, it seems to be a much later entry. We were really much later entry. And
no, I have one general question here. You see, it's very interesting that, first of all, this 7-day thing was common across continents. And then the names were also exactly same in all the civilizations, you see.
Not just for the weekdays, right? Even for the zodiac. That's because it's supposed to come. I think the 7 days have a Greek origin, and the zodiac definitely has got a Babylonian origin.
I see. Because, it is Ravivar or, or Sunday, everything is to do with the sun that particular day.
No, these two are not from India.
Ah, okay.
The zodiac is definitely not from India.
Okay. I see. Okay.
See, because this was a question that was asked even in the last time, right? If the Varas had an Indian origin, how come the Rahu and Ketu were not taken into account?
Okay.
It's not. It's basically not from here.
Yeah. Okay. And so we don't have this reference to Varas much in the ancient texts, is it?
No.
Okay.
No. And the second thing is, I have not mentioned it here, but according to the Indian system, the distance between Earth and these planets, the way the entire system is placed, like there's Mercury, Venus, Sun, and then it doesn't fit in any one of these orders.
Okay.
Nothing fits.
Okay.
Yeah, of course. And then this is how the months were measured based on the lunar calendar. What's interesting here is there are two different kinds of months. One which starts on a new moon and ends on a new moon, which is called the Amantamasa, and the other is the Purnimantamasa, which begins on a full moon and ends on a full moon. Most of that, the coastal states and Tripura and Assam follow the Amantamasa starting and ending on a new moon, whereas the other states follow the Purnimantamasa, especially Odisha and other states. So there are again two different ways of calculating the month. The reason I'm mentioning all this is there's always this confusion. Why is Diwali on n-1 day for one set of people and on day n for the next set of people? What is happening? These are the small calculational changes that lead to sometimes the festival falling on the same day for everyone, and sometimes it's different. And it's very interesting that across the border between Tamil Nadu and Andhra, things change drastically. And then there's yoga. Yoga is basically the longitude of sun and longitude of moon on a given day divided by the 13 degree 20 minutes. And this is the time through which the system moves through this particular sum. This is, again, yoga simply means adding of the two. And do I have? Yeah, I have a list of yogas. Are these arbitrary? Yes, they are arbitrary, but this is because they believe that the prime sources of light, which are the sun and the moon, influence the person concerned, and they were used, person or even agriculture. And so, of course, there are the solar and lunar months. The names are slightly different. Like, if you talk to one set of people, you will hear it as a Bhadrapada, and the others will call it a Purva Bhadrapada. Depending on the name, you know whether it's a solar month or a lunar month. Again, small but subtle change, important changes. There have been very specific jargon words for both geometry and astronomy, like Nabha is for space and Bha is for sky or light, and similarly for geometry. Now, all this is from the Siddhantic period. So these were the ones which were used to write the sutras, the shlokas, which gave the math of how to do the astronomy in those days. Specifically, angular measurements, which are important for astronomy, had names like Kala, which were degrees, and Lipta and Vilipta. And these were all based on the sexagesimal system and not decimal. This sexagesimal is mostly from a Babylonian origin. So again, there is reason to believe that there was a back and forth exchange of knowledge between Babylonia, from Egypt, Alexandria. Basically, whatever was Greek was not, when I say Greek, it's basically from Alexandria and that area. And back and forth, because Indian astronomy again went back to the Arab countries. And of course, there was an exchange across to China also. Sorry, there is 1 0 missing here. The 1,000 years between Lagada and Aryabhata saw an evolution of astronomy, and it is during this period that texts called Siddhantas which were composed, and Varahamihira analyzed 5 of these, and that's called the Pancha Siddhantika. So Aryabhata I was the pioneer of modern mathematical astronomy in India, and Varahamihira had 3 major works, which is Pancha Siddhantika, Brihad Samhita, and Brihad Jataka. Aryabhata, basically, this is the reason I've been saying, I'm sorry, because Aryabhata has only 1 T, unlike the other Bhattas. This has been confirmed variously. And Sesh, this is the figure of the hypothetical Ayuka, right?
Yeah, that's correct.
So he wrote a lot about maths and astronomy and everything else. One of the significant changes that Aryabhata did to the traditional form of thinking was that for him, the day began at midnight and not at sunrise. He was also the first to put his name to his book. The previous books were attributed to people, whereas here he wrote his name and said, I'm the one who's writing it.
So this is the beginning of patenting.
This is the beginning of letting us know who's saying what and taking responsibility. No, this also reflects on an Indian, mindset of saying that a person is not important, the knowledge is important. So people refuse to put their names to their creations, whether it was temples, sculptures, books.
Can I just make a small comment here, completely off about these names?
Yes.
There is a statement which I have read that some equation, this is the equation which is called the Einstein-Schrodinger equation by Wheeler and Dewitt, and as Wheeler-Dewitt equation by everybody else.
I see. Okay. Okay. All right. Anyway, this Arya Siddhanta is a lost work on astronomical computations, but it's known through the writings of his contemporary Varahamihira. Now, why is this statement important? It's because, remember I told you that wherever there are Shastras or texts being written, whenever a person wants to either take the work forward or, contradict the work, they were supposed to quote the previous work in totality. So although the original texts are lost, their copies were available in the works of the later people. So Aryabhata's work does not exist as his work, but whatever Varahamihira has quoted is there, and there are reasons to believe that this is correct because that was the rule of the day, that you had to quote it in totality without distortions before you start agreeing or disagreeing with whatever data is there. Now, from Aryabhata, 2 schools of astronomical thought separated. One was that of Brahmagupta, who severely criticized Aryabhata's assumptions, and sometimes fairly, sometimes inaccurately, and this went back and forth. And the other was, the other school which emerged was that of Bhaskara. The Bhaskara too and others followed Brahmagupta. The other school went on to become what is now called the Kerala School of Mathematics and Astronomy, those who followed Aryabhata. So there was one stream of thought which continued Aryabhata's thought, and the other which followed Brahmagupta's thought. So one of the simplest difference between the two being that one said believed that the day began at midnight, and the other said which believed that the day began at daylight. And that's the simplest of the two differences. Varahamihira is somebody who was prolific. He's supposed to be humorous and have written about everything under the sun. He was a contemporary of Aryabhatta, and he wrote something called the Pancha Siddhantika, where he compared 5 of the 18 Siddhanta texts that were there. And he mentions that the Greeks were highly respected astronomers. So again, there was a back and forth exchange of knowledge. And his magnum opus was, of course, the Brihad Samhita, which is mostly a book on astrology, but includes scientific proofs that eclipses are caused by shadows and not by Rahu Ketu, the mythology that I had just mentioned. And he's the only person who writes about comets. And in those days, the line of reference was the Ujjaying Meridian. This is the straight line, and it is believed that the 12 Jyotirlingas lie in close proximity to this, meridian. All the major Shiva temples will be somewhere there, from Kalahasti to thing. It's also believed, and this I'm reading quite a few people say that the Ramayana's Lanka was not the Sri Lanka, but now submerged area, which was somewhere out there. There are, textual references where Hanuman jumps in a certain direction to reach Lanka, and it is not in this. And so, no matter what, even if we don't take reference to the Ramayana Lanka.
Madhurima? Yeah. I mean, on what basis is this meridian drawn? I mean, how was this decided?
This is the starting point is, of course, the equator, and no, I mean, why Ujjain? I don't know.
But why this longitude? I mean,
why Ujjain? I don't know. I mean, that's supposed to be the place which had the old observatory, of which.
Oh, I see.
And, Bhaskara too I think Bhaskara too was in charge of the observatory.
Oh, I see. Oh, acha, somebody has been, Abhinav Bharti has been, Varamihira was from Ujjain, I see.
Varamihira was from Ujjain, I'm not too sure, but definitely Bhaskara too was from Ujjain.
I see.
Also remember the Varamihira was from Ujjain, I see. Okay. Now, also the other thing is, one of the influential kings of those days was Vikramaditya. The Vikram Samvat.
Okay. Vikram Samvat.
Who was from Ujjain area. So it had their influence.
Okay. Much. Okay.
So, I mean, why Ujjain even I don't know. I'm not sure. So this particular meridian was what is used for Panchangas and for all the calculations. Whatever calculations were done with respect to that. And then there is always a small correction that is done for your local time. And that is also given in the Panchanga. And this is what I was saying. I've seen my aunts who were not really educated, who could do even the smaller calculations without much training. So this is a tradition we have really lost, and sometimes I feel bad about it. I think we should all go back to reading Panchangas just to keep that calculation power in us alive. So Sage, to answer your question, there is something here. I mean, if at all it interests you, it says, as per the Surya Siddhanta, Ujjain is geographically situated at the precise spot where the zero meridian of longitude and the Tropic of Cancer intersect, and it is considered the navel of Earth. Something to do with the Shiva tradition.
Yeah, I think then it's just like Greenwich is an arbitrary thing. Now, I mean, Ujjain was at that time. Yeah, I see. Okay.
I mean, Ujjain has always been a place of importance from the Tantric Shaiva.
Okay.
Again, you can see that while all other Siddhantas determine time with Ujjain as the prime meridian, the Romaka Siddhanta says that the day starts with sunset at Yavanapura, which is most probably in Alexandria. So there have been other meridians. I mean, this was for India. And the small changes was called the Deshantara, which people applied to the local space. And after some time, I'll be discussing about this Madras Observatory. The Indian meridian moved from Ujjain to Madras for a very, very different reason. So the Madras meridian was used for calculating time, especially for railway clocks. That was interesting too.
Madhurima, just on a lighter note, Instead of Romaka Siddhanta, it should be Romana Siddhanta. This is Rome.
Yeah, but I mean, I'm surprised with the name of Romaka because it should have been Yavana and not Romakas.
Or Romana, because it's from Rome.
Yeah, I mean, I don't know why it is that, but yeah. No, seriously speaking, I think Romaka Siddhanta is attributed to, among the 5 Siddhantas that Varahamihira had written about, the Pancha Siddhantika, 2 are attributed to Romans. I mean, they say there were Roman people staying in India in those days and writing.
Oh, right? Okay.
So it's really not a joke there. So coming to the classical era, I mean, this is something most people are aware of, but Brahmagupta was the first one who contradicted Aryabhatta. He believed that, he theorized that all bodies with masses are attracted to Earth, and there's a lot that has been written about all these people. And there's a tremendous improvement in the calculations, astronomical calculations in this period. Bhaskara I, who composed 3 texts again, and he talks about planetary longitudes, helical raising and setting of the planets, solar and lunar eclipses, phases of the moon, and so on and so forth. Lalla writes about the planetary positions and graphical representations, and his works were later followed by other astronomers like Sripati and Vateshwara, and mainly Bhaskara too, who's a towering personality. Now, Vateshwara was a follower of Aryabhatta, and he became very famous because he was a critic of Brahmagupta. Brahmagupta criticized Aryabhatta and Vateshwara criticized Brahmagupta. This again, this is my pet peeve. So, nowhere in Indian tradition did it say that you cannot contradict your teacher or you cannot contradict existing knowledge. It only says contradict with enough proof and be polite about it.
I think this is very, very important to be underlined.
Yes. Yes. Because there's some wrong notion that, you cannot question what is there in the Shastra. In fact, Shastras have been questioned all the time. Questions have been raised and they have contradicted the biggest stars. It's not just Newton and Einstein whose thoughts have been contradicted, making the modern scientists great people. We have the tradition. It's somewhere we have just lost that ability. Yeah. I mean, anybody who knows the system will understand why I feel so passionate about this. And repeating that you can and you should be criticizing and be critical of, you should be critical and you can criticize any Shastra, provided you have the proof for it, provided you don't misquote, and provided you're polite about it. That's all. So Bhaskaracharya too was the last astronomer and mathematician in this era. He's the biggest star in this firmament. So among his many, many masterpieces are the Leelavati, the Bijaganita, and so on and so forth. He was the one who headed the observatory at Ujjayin. And then there was Sripati and Mahendra Suri. Mahendra Suri is important because he wrote about the Yantra Raja, this particular device which could do a lot of calculations, and it was a mechanical device. And there the parallel was the Kerala School of Mathematics and Astronomy, which starts with Madhava and then goes all the way to Nilakanta Somyaji, who wrote the Tantra Sangraha, and Achyuta Pishirati who wrote the Sfutanirniya. Tantra Sangraha, I know, has been worked upon extensively and translated into modern day scientific terms by Sri Ram and others. Professor Sri Ram, this is what I was asking some of you guys before. He had given a talk on ancient Indian astronomy at CUTN a couple of years ago. And he had also helped us in the first few batches know him as somebody who has taught them physics. So there are quite a few people who are working on these in a very scientific manner. I mean, he would be the right person to talk about the Siddhantas. Coming to the Jantar Mantars, because here we talked about the devices that, for the first time you're seeing something called a device. So the Jantar Mantars are 5 observatories that were built across North India by Savai Jai Singh in Jaipur, Delhi, Varanasi, Ujjain, and Mathura. The Mathura one has been lost just before the revolution of 1857, and these are the various locations. There are 2 reasons given for why the Jantar Mantars were spread across a larger geography. One was like the precision of the instruments would increase if they are separated in distance. The other was like this king who was from the fort of Amber just wanted to establish his kingdom and say that this is my domain.
Madhurima?
Yep.
I just wanted to mention that when talking of Jantar Mantar, one is reminded of Ratnashree. She had worked extensively on the Delhi Jantar Mantar. I had been there with her. Yeah.
No, I think you should tell the audience about her for a minute.
Yeah, I mean, actually, Ratnashree, she was a PhD student, 3 years my junior in TIFR. And later, she joined the Nehru Planetarium in Delhi. And she completely changed the entire way the planetarium does. And she actually went to Jantar Mantar in Delhi, recalibrated the thing and did extensive research work on that. Very unfortunately, about a month back, she passed away due to COVID.
No, I've seen enough posts to, I have not known her, but I've read so much, people saying what a big loss it is to the entire community of astronomy.
Yeah.
So just to give an idea of the possible, genesis of, I'm coming to that, Kaviraj. I'm coming exactly to that. Jantar Mantar comes from Yantra Mantra, and Yantra Mantra and Tantra are supposed to be 3 major ways of religious worship. So the first picture on the left here is a brick Vedic altar in the form of a falcon, which was used for they said that depending on why you're performing a yaga, you had a specific shape. And there are enough videos on YouTube, you should watch them. Just to create this, you needed to know geometry. Like you have a rope, this was what the Sulva Sutras were. Here, you have to place 5 layers of bricks, 1, 3, and 5 in one particular fashion, 2 and 4 in another fashion. And the bricks here are everything from triangles to trapezoids to rectangles, and they have to be baked that way. So how do you create such things using a rope? And that's what the Sulva Sutras had. So the origin of a lot of this measurement techniques and the geometry came from the Vedic altars. Also the tradition of mandalas, of drawing figures, geometry. So this is the Buddhist mandala, and this even today we have these coming to us in the form of rangolis that are done in the houses. And what is here is what is called a Shri Yantra. The word Yantra comes from this. So Yantra is a 2-dimensional structure which is used to represent something which is cosmic. So the mandala of Buddhism is the Yantra of Hinduism. And these particular 2-dimensional and 3-dimensional structures were used as forms of worship. So when the devices were built, they said, look, we already have this tradition of geometry and structures, which was called the yantra and the mantra. So that's the Jantar Mantar. That's how it got its name. And this is kind of well known. Origin. Somebody's mic is on. Yeah. So just to give a feeling for what these yantras were doing, those devices were doing, this is, there are various names, very traditional names given to them. And depending on the shadows that they cast, there were various calculations that could be done. One could have a full lecture just on this, but this was just to give you a feeling for what they are. So let's quickly move. I know I'm past the 1 hour mark, so let me quickly move to the colonial and the post-colonial era, and we can close with that. In the Vedanga Jyotisha, the year began with the winter solstice, and these are the various calendars that are there in India. The Hindu calendar counts days starting from the Kali Yuga, which is believed to be on 18th February in the year 3102 BCE. Right. There is the Vikram Samvat era, which was introduced about the 12th century, and it starts at 57 BCE. The Sakha era, which is used in some Hindu calendars, and it is from the year 78. This, at least for some old timers who used to listen to TV, on Tamil channels, they will say Sakha, and you have the Sakha mentioned there. The Saptarishi calendar had its epoch at 3076 BCE. Now, given all this post-independence, the government of India decided to have a national calendar prepared, and this was proposed by Meghnad Saha and Lahiri in 1952. And they prepared the national Panchang and the national calendar, and that continues to be the Lahiri calculations. And this is the national calendar are the ones which are used for the Panchanga since independence. It is also to be noted that in many areas, the dates are reckoned from the birth or from the coronation, not the birth, but usually the coronation of the local king, such as the Puri king in Odisha, and so on and so forth. So when the birth charts are written of when a child is born, it's mentioned that this child was born in the 32nd year of the king so and so. So that's how the dating was done. Dating simply meaning dates, Sage. Okay, the first modern scientific astronomy with Indian observations is the Madras Observatory. The Madras Observatory was an astronomical observatory which started off as a private observatory and then later was managed by the British East India Company. And the main purpose was to establish a navigation and mapping, and so recording time and everything. In later years, this observatory also made observations about stars and geomagnetism, and I think it closed down in 1931. But this was the starting of a different kind of...
No, Madhurima. It didn't close down, it just changed its name. It is now called the Indian Use of Astrophysics.
At Madras, because yes, this is a thing
it moved from Madras, but Indian Use of Astrophysics continues its thing right from the Madras Observatory.
I see. I didn't know that it moved to. Indian Astrophysics is a continuation. Okay, thanks.
Yeah.
I didn't know. Okay, that's interesting. That's very interesting. Okay. Now, in July 1983, following a famine in Madras Presidency, there was an urgent need to understand the atmosphere and environment in a much better way. So what is nice is a committee chaired by Lord Kelvin was the one who decided to establish a solar physics observatory at Kodaikanal, based on the fact that it is in the south and dust-free and high altitude and everything else. And the first observations commenced in 1905. Sesh, I will leave to you to answer this if somebody asks a question about the Evershed effect and the electrojets.
Okay. Was it 1909 or 1905? I don't know. Because I think there is a plaque outside. In Kodaikanal Observatory, there is a guest house called Evershed Hall. There, I have been fortunate enough to stay for 2 weeks. And it's a huge bungalow outside which there was a plaque. I think this is basically when you look at the sun, there are convection currents which are there on the sun. So while hot material wells up, cold material goes down, they are called granulation and supergranulation. These are not exactly the same, but related to this. And this is called the Evershed effect. And it was first observed from the Kodaikanal Observatory.
I could be wrong because a lot of my reference is from the internet. So it could be.
I think it is. I am not sure. I think because as my memory goes, the plaque outside the Evershed Hall mentions it as 1905, I think.
I see. Okay.
Yeah.
But anyway, this is unique because I have been, I've seen this observatory from outside, and I think many of our students have also visited. But the historical importance was something I was not really aware of.
So in September 1919, we had a young astronomers meet. Just to clarify, I was called as an old astronomer to preach to the young astronomers. Okay. So there we had seen, and then they have got world's oldest continuous record of the sun till date.
Wow.
Right from those very old days, they have all records. So what happens is, when you want to study the pattern of change in the sun over many years, it is this which is referred to.
I see.
Yeah.
Wow. Wow. That's really nice to know.
Yeah.
Okay. So quickly moving forward, modern Indian astronomy started in the first decades of 20th century, when India, basically the scientists' names that are associated are Meghnad Saha and Homi Bhabha. So that's Saha and this is Bhabha. And they work from institutes like Indian Institute of Science and TIFR in Mumbai. Now, Homi Bhabha was interested in cosmic ray research and conducted balloon-based experiments first from IISc and then TIFR. And
Madhurima, just one comment.
Sure.
His first experiments started from his aunt's house in Bombay.
In Bombay, okay.
Yes, yeah.
Okay. And the balloons are even now used for for all these weather measurements, especially near airports. They do let the balloons go. So it's a technique that's still used very actively. And Govind Swarup, again, somebody whom we lost very recently, was the person who was responsible for two great telescopes being built. Both the Uti radio telescope and the Giant Meter Wave radio telescope near Pune, right? So these are
That's correct. Yeah.
So various locations of the observatories that exist in India, just to get a feel for where they are. Quickly concluding, we have gone from the Leelavati of Bhaskaracharya. I think many of you know the story of this. What is sent in a balloon? Sensors are sent in a balloon, Kaviraj, so that the measurements can be made from higher altitudes.
Yeah. See, in fact, I don't know now, but till recently, till when I was doing, some years back, from Hyderabad TFR facility, they used to send up what is called the zero pressure balloon. These balloons used to take, to make gamma ray observations, X-ray observations and all, from a height of about 36 kilometers above the Earth's surface.
Right. Okay, coming back to Bhaskaracharya, this is Bhaskara II who wrote this book called Leelavati and named it after his daughter. And the story goes that he made some calculations for her marriage, and it didn't work out, and she was widowed very early, but she was an extremely bright scholar who would ask him a lot of questions. And Leelavati is the conversation with her are these shlokas, and this is a very nice book to read, Leelavati. Now, I think Professor Ram was here. I don't know if he's still around in the meeting, but Dr. Rohini Godbole, he had a compilation of the biographies of women scientists in the country, because there's a minority, and named it as Leelavati's daughters. Why am I mentioning this now? It's because one of the statistics shows that the number of women astronomers is pretty low. And this is the work by Preeti Kharb that I have taken. So it shows the ratio of total faculty in astronomy at various institutes. But the fact is that when it comes to doing research as research scholars, the women are still there in fairly large numbers. So there is a huge leaky pipeline, and there is a reason women need to be encouraged, and we need more women astronomers. We need more astronomers, and we need more women astronomers. IIT is, I'm sorry, not IIT, but CUTN being a place where we have had a very large women student population. I think this should be an inspiration. You have a lot of space to come in and contribute. We need you here. So this is the reference for this. Thank you very much.
Thank you so much, ma'am. I hope the audience is having some questions. They can unmute themselves or they can write their doubts in the chat section.
Yes, you can unmute and ask.
Ma'am, can I ask you a doubt?
Yes, please go ahead.
I am guessing that some audience or some participants may be having this doubt. The question is, why is the pole star changing every maybe some 26,000 years? So,
Sampurna, our co-coordinator, do you want to come in? Or Sesh?
It's a classical mechanics problem. The physics of the spinning top. So if suppose you have a completely spherically symmetric object and it is, oh, okay. Yeah, you can see my beautiful face. Okay. Okay. So, yeah. So what happens is, if suppose you have a completely symmetric, like a ball, and it is spinning, and it doesn't matter from which direction gravity is acting, it will keep spinning with the conservation of angular momentum. The axis will remain same. However, if it is not symmetric, but on one side of the axis, the mass is slightly more than the other side, then there is a torque which acts on it, and the axis starts wobbling. Now, the situation in the Earth under the sun's gravity is that the Earth is slightly heavy on the top and slightly light on the southern hemisphere, as a result of which the north-south axis wobbles. And it is near the pole star now, but it is wobbling, and that is what takes 26,000 years. If you had noticed the graph which Madhurima showed, it starts from minus 13,000 to plus 13,000 as the graph moves. That is the 26,000 year cycle. And that's why this moves. Yeah, like that.
Thank you so much, sir.
Any comments, questions?
Ma'am, I have a set of doubts.
Who is it?
Kaviraj.
Yes, Kaviraj.
Ma'am, so before the invention of telescope, people worshipped 9 planets. Is it true or they can say not true? Like in temples, we used to see 9 planets.
So even now you have the 9 planets, Rahu and Ketu being the 2.
So how did they watch? How did they see the planets without telescopes?
The planets that are listed are those which are visible to the naked eye.
Okay.
The Rahu and Ketu are the 2 nodes. Let me just get back to this. It's all within the visible realm only. Yeah, so here you can see this, right? These 2 points, the nodal axis of rotation here, or during the ascent, as it turns around, these were called Rahu and Ketu. So these were added to the list.
No, what he's asking is about Navagraha.
Yeah, Navagraha.
Navagrahas have sun and moon and Rahu and Ketu. So 4 of them are already out.
Yeah, the Nava portion is just a coincidence. Yeah, Uranus, Neptune, Pluto was not there, but Rahu, Ketu, and Rahu, Ketu, Sun and Moon, they were all added, and that's the way it was. Yeah. Oh, and the Earth is not there, right?
Earth is not there. No.
So Earth, Uranus, Neptune, Pluto were not there, and inside Sun, Moon, Rahu, Ketu was there. That's how it still makes 9.
Another thing, like Indonesia is one of the most biggest country with more Muslim population. Like now, I'm not going to the religious part, but just saying, like our history is like we can see our mythological stories in the form of sculptures. And how do you think about
There's nothing to think. We all know
exactly.
solar
No.
influence.
So it's like I was
It just shows coexistence.
No. This is very well established, Kaviraj. The Chola kings had their spread of power all the way to Bali, and even slightly towards Korea. Like the entire region was, Rajaraja Chola was somebody whose influence went across entire Southeast Asia along the coastal lines. And Ramayana and Mahabharata have a huge presence in Indonesia. Not just in Indonesia, but in Cambodia, in Thailand, and everywhere else, because Ramayana is performed as a performing play everywhere there. The Cambodian temple of Angkor Wat is for Vishnu, and the longest history of Ramayana being performed every day without a break is in Indonesia, which I was. I should say I was fortunate to watch because it's a beautiful performance. And when I asked the same question to them, asking them, like, you are Muslims, is there a contradiction between what you believe in and what you're performing? I liked what I heard, and I think this is something all of us need to respect. They said that Hinduism is our culture and Islam is our religion, and we are very specific about these two. These two cannot change. One is our historical culture. The same idea is followed in Nagaland, where they're culturally, they still stick to their roots of music and art and craft, but the religion is Christianity. So there are communities which strongly adhere to both. So Indonesia,
in fact, their airlines is called Garuda.
Their airlines is called Garuda, and they embrace their culture without hesitation.
Talking about the connection, this one, I mean, maybe it's not directly related to the talk, but this is an interesting thing. This I read in a book called It Happened Along the Kaveri. And the interesting thing is, in Cambodia, once there was a king who died without a heir. And they all sat down and discussed like how to proceed. Then they discovered that in their lineage, there was one person who has connection with Pallavas. So one of the Pallava prince had gone from here there to take up the kingship, and then it continued.
That is one, and even the other way around is mentioned, that one of Pallavas themselves at one point got back
from there. Is it?
Yes.
I see. Okay. It's called the exchange program.
Yeah, no, this is actually something, and even Korean language has a lot of Tamil words.
I see.
Because one of the Korean old ancient queens was a Tamil princess.
Ah, okay.
There are temples in Indonesia where, facing each other are Buddhist and Hindu temples, because the husband was Buddhist and the wife is a Hindu queen. And the temple is built by the Buddhist king. I mean, the husband is the temple for the wife and the other way around. People have been tolerant. People have respected each other's cultures and lived with it. If at all there is a take-home message, it is, I would say two things. You can and should question everything that is taught to you. Be polite about it, but you can. And two, be tolerant. Information and culture has always exchanged across the globe. We have never lived in isolation. Yeah. Any other questions?
Can I add a small story with the?
Sure.
The part which is at Vishwamitra and Trishanga Shor. Can you go the slide? With the slide it will be.
Yeah, I'm just coming to it.
Yes, ma'am. So thing is, Vishwamitra was not called Vishwamitra. So before that, he was a Raja, was a king called Kausik Maharaja. He should be called. Then his country was undergoing famine, and people were dying without any food. So he went to Vishwamitra. He went to Vasishtha Munivar. Then he saw a cow which gives everything, like which gives food, unlimited food supply, everything. And the Kaushik Maharaja asked for the cow, but he didn't give it. he didn't give the cow. So Kaushik Maharaja got upset and asked, like not upset, angry. Then Vasishtha Munivar said, if you can stay and pray and ask wish to God itself. Don't ask me, he said. Then he followed Brahmacharya for so many years to beat Vasishtha Munivar. So at that time period, Trishanga was a man who went to Vasishtha Munivar and he asked, "Can I go to the heaven?" He asked. So Vasishtha Munivar said, "A person who is not dead cannot go to heaven." He said. Then Trishanka was very upset and he was crossing, and he met Vasishtha. He met the Kaushik Maharaja. Then Kaushik Maharaja said, "Why are you upset?" He said the story which happened between Vasishtha Munivar and Trishanka.
That is true. That's a long story. And see, the thing is, I was not going into the mythological stories because even with Agastya, there is a lot about Shiva's wedding and how Agastya sent south of India, so on and so forth. Yeah. So the idea is not to discuss Hindu mythology, but to look at its association with astronomy.
Yeah, that part. That
that was the only intention for putting it there.
Yeah. So that's how he created a heaven for him.
That's right. No, I mean, if you have seen, I've not elaborated on any of the stories because that's a long story in itself. And there is also the idea that north was considered to be heaven and south was hell. So north pole, south pole. So there's a lot that can be interpreted, but these are also, at some level, these are individual. Malavika, similar to how we use mathematical techniques to compute auspicious time, did the Islamic community have something similar? I don't know. I don't think so, Malvika. I am not the right person to answer this question, but I would only guess that it's no, because the need for making these calculations came from the Vedic culture of doing yajnas. And that's why the Sulva Sutras are mentioned whenever we talk about Indian astronomy. Because the whole thing is traced back to the Vedic altars, the fire altars, and the need for performing the homas at the right time. So it's a cultural thing. So remember the first slide that I put, that a lot of interpretation actually depends on the cultural values that a person has and how they interpret the data that is given to them. So I believe no. This is very local here. Does the Vedas talk deeply about the creation of universe? Alan Sunny, yes, and Vedas, no, not really. The creation myths come at slightly later dates mostly during the Puranic period, slightly before that, but Vedas not much about cosmology of, not about creation myths. The Rig Veda is mostly related to nature worship and talking about gods like fire and water and rains and so on and so forth. The creation mythology starts during the Puranic period. So I would say no. That would be my brief answer, Alan.
Ma'am?
Yeah.
Thank you for the answer. And I've heard that I don't know much about it, but I've heard that in a philosophical point, people say that the word Om has it's a cosmic sound and it's related to the Big Bang. Like, is there any scientific accuracy, or it's just a philosophical idea?
I will leave it to Sesh, because if I say something, it will be pretty harsh. Because I would say Om is a sound wave, and where did that come in Big Bang? And that will be the end of my answer. But maybe
absolutely no. Absolutely no. I mean, you see, I think what one should realize is both these branches of human intellect are respectful in their own ways. But, mixing these up is just insulting both of them.
Exactly. And see, this was the reason for me to project this particular slide, Alan. creation theories were different for different streams of thought. And one says Hiranyagarbha was the origin. There was this cosmic golden egg, which was the beginning. And the other says it's the Purusha, the Virat Purusha, and so on and so forth. These differences have continued because there were no concrete experimental evidences. And somewhere we have these, the religion and science have become two distinct streams over the last few centuries at least. So long as people were looking with the same, sight, like, with the same eyes, they were willing to correct and go back and forth. And hence the number of nakshatras, the stars, the planet, all those are common. Whatever was experimentally proved was common. That was precisely the reason I put in that slide, because creation mythology or creation theories are completely different from one school to the other, and people don't agree about anything. Each school has its own, if you look at the Vaishnavas, it's one. Even within the Vaishnavas, there are schools of thought which are different. But the fact is, because there were no experimental proofs, we didn't have instruments. I think one of the biggest lacuna of Indian astronomy in the traditional sense being taken forward was that we didn't have telescopes, we didn't have instruments. So there's no way of knowing the origin of the universe without actually probing deep into the cosmos. What can we comment about the statement that sound is the basis of creation? Who's this? Malavika. Malavika, this I think we will, sound is the basis of creation. I want to know where it came from. I'm also curious to know, but as far as my understanding goes, it can be dated back to the Dhvanyaloka and the Dhvani theory, which has its origins in the Advaita school of philosophy. Basically, the question that was asked is, if I make a sound, how do you know what that sound means? What is the relationship between the Vak and the Artha? And the entire creation was seen from that point of view. It was a philosophical school which was trying to understand how the human brain works. So one school was asking a question like, based on sight, what is called the Chitra Turaganyaya. That is, if you look at the picture of a horse, how do you know it is the picture of a horse? That it is unreal, but it is a horse. So there is cognition. So actually, it's deep philosophy. I believe it should have something to do with the Dhvanyaloka and maybe post 500 Common Era. But I would like to know where this statement. Even I would like to know from where this thought originated. But my take on it, I'm guessing it should be Anandavardhana's contribution. What is the significance of the swastika symbol? Swastika symbol is supposed to be something in motion, but keeping the center.
Madhurima, I was also thinking, wasn't swastika supposed to be the sun? Those things are the rays coming out from the center. Yeah,
exactly. The sun, and it's also movement. So there is a cyclic movement, and a cyclic movement, even the cyclic time is supposed to represent, infinite time from forever.
Yeah.
It's all that, but
from ever to forever.
Exactly.
Ma'am, can you take one more question?
Yeah, please.
Okay, ma'am. I don't know if it is from Shulba Sutra, but I had read about an experiment where stick is buried in the ground, circle is drawn around it, and we measure the shadows to find the exact east-west direction. So can you please comment on that?
I think that is from the Sulva Sutras. If I'm not mistaken, that is from the Sulva Sutras. For example, every household which maintains the fires are supposed to have 3 different fires. One for the house, one for the ancestors, and one for the rituals. One was supposed to be a circular altar, one was a semicircular altar, and the third was, I think, a rectangular or a triangular one, but with the condition that all of them should have the same area. And that was the interesting part. Now, if you have to have the same area, how do you do that without a scale or a pencil? So they say that put a stick, take a rope, draw a circle. Now, draw the two perpendiculars. Draw circles from each of the perpendiculars, and on one side take 1/3 of it and draw. So there are very strict rules, and you actually end up getting the same area. So what you're mentioning is from the Sulva Sutras. I also, this is my interpretation, but I also believe that we have this tradition of Pandakal, where at the beginning of any auspicious event, you have the placement of a long stick in front of the house. It was called the Jajara Puja, and that is also mentioned in the Natya Shastra, which is really an old text. I somehow now am beginning to believe that that Jajara or the Danda that was placed is because your north-south alignment changes every day with the Earth's position. So you place it there, and then you mark it with a lamp which has to be glowing, burning for the next as long as the event occurs. So the north-south is known, and any ritual that has to be done facing east, facing north, where the cardinal directions are. So this seems to have an influence. And right now, of course, like this famous cat that is tied to a pole, I think we have forgotten. There's just one pole that is kept there, and some column or some lamp which is lit. I believe that these had practical values, and this danda is something that I strongly believe had to do with finding the cardinal directions. Say, you were trying to say something?
No, nothing.
Yeah. So yes, that's basically from the Sulva Sutras.
Okay, ma'am. And I have also read about the architectural significance of all this geometry. Somewhere, like in Padmanabha Swami Temple in Trivandrum, where that temple's gopuram is exactly designed so that during summer equinox, the sun goes down exactly through the middle of that gopuram.
Those have been done, I think, across so many temples. I mean, there are many temples even around CUTN where exactly on some day the sun's rays will fall straight onto the idol.
No, I have a problem with that. I have also come across that thing. You see, the point is, Padmanabha Swami temple is such an old temple that because of the precession of the Earth's axis, directions would have changed. So maybe at some time it was, but if it was at that time, it won't be always.
No, this also is a way of dating the temples because, frankly,
yes.
I'll tell you something. This I know I will be going against the grain of a lot of belief, but I can't help it. A lot of antiquity that is attributed to the temples is not based on architecture, but is based on what are called the Sthala Puranas. And now Puranas themselves are from 200 Common Era to, I think, 1800 Common Era. So to quote something as a reference which is only a few hundreds old and say that this temple is 5,000 years old doesn't really make sense. So these are really the ways. This is what is now called, I think, Astro Archaeology. Looking at these kind of statements or about astronomy in texts or, like you said, in temples, people try to date them. So yeah, I mean, this is interesting in its own way. Like somebody should actually do this calculation and find out how old the temple is.
Yeah.
Thank you, ma'am.
Yeah.
I see that there are no more questions.
Great. Nice.
Shall we come to the end of the session?
Yes, please. So thank you all for this opportunity.
Thanks a lot. Very nice.
Okay. So, ma'am, you were saying something?
No, I said bye. I mean, you can close the event.
Okay. So, by this, we come to the end of the session. And I first of all thank Dr. V. Madhurima for giving this wonderful talk on Indian astronomy. And I also thank Dr. Sheshadri for being a part of this discussion.
Hey, I told you last time, stop these, this barrage of thank yous.
Absolutely. I don't want them to. Thanks.
Yeah.
So I thank all the participants.
Let me close it by thanking all of you for being here for such a long time, 1 hour and 45 minutes, and listening to me. It was wonderful listening to you, and we'll come back to you with much better events. Ta-ta.
Great. Thanks. Bye.
Bye.
Thank you so much, ma'am.
Bye.